These are the notes for lesson 1.3. This is the second part of lesson 1.3, where we are learning to factor a quadratic. All right, so we've already factored a couple different ways. We've factored into two binomials. We've factored into, we've used a difference of two squares and factored that. In this lesson, you're going to be able to solve a quadratic equation by factoring, once again, but you can also model a situation using a quadratic equation. So starting off here, let's just discuss what a quadratic equation is, and that's going to be an equation in either of these three forms. Okay, so we either have the standard form, remember the ax squared plus bx plus c, or we have the vertex form, or we have the intercept form. All right, and you'll recognize this as just two binomials multiplied together. And the intercept form gives us the two places where the parabola crosses the x-axis. All right, and that's what we mean when we're talking about x-intercepts. So x-intercepts are the points on the x-axis where the graph, or the parabola, intersects the x-axis. All right, so if I was looking at this graph that I have on my notes page, this point right here and this point right here are points where the graph hits the x-axis. And I can say, well, it hits it at -5 and it hits it at +2. So if I was thinking about, well, if that's the case, then that means that this one binomial would be x plus 5 and this other binomial would be x minus 2. Remember that that would be what y equals, because we were able to find the x-intercepts by just setting each one of these separately equal to 0. So if I FOILed this out and I said x times x times -2, etc., I could actually go back and say, well, I know exactly what the quadratic function is for this graph. It is x squared plus 3x minus 10, because all I would have to do is FOIL this information and I would be able to arrive back at the standard form of this equation. So you're going to get better and better at understanding how these 2 points, the x-intercepts, can help us get back to the actual function that it started at. So if we look at what we're really doing when we solve a quadratic equation, when we go to solve it, we're really just finding the x-intercepts, sort of like what I did here. And then we're also finding the zeros. Sometimes it's also called finding the roots. Okay, that's another word that we can sometimes use, or solutions. Okay, so what are the solutions of this function? What are the roots of this function? What are the zeros of this function? That all means the same thing. It all means what are the x-intercepts? Where does the graph hit the x-axis? All right, and let's remember then that the zero product property, we had this in a previous set of notes. If a times b equals 0, then either a equals 0 or b equals 0, or both a and b equals 0, because anything times 0 is 0. All right, and then another way to say that is a product of factors, meaning two numbers that are multiplied together, is 0. And you may remember this symbolization from geometry: if and only if one or more of the factors is 0. Is 0. Okay, so a product of factors is 0 if and only if one or more of the factors is 0. So I just stated this in another way. One is stated in red and one is stated in black. All right, let's take a look at an example on the other side of the paper. And here we have the steps of solving by factoring. So we want to find the zeros, the roots, the solutions of the quadratic equations, and we're going to do that by setting y to 0 or setting one side to 0. Okay, and that sometimes means that we have to undo some things so that all of our terms are on one side of the equation and 0 is on the other side. We'll talk about that in just a minute. We also have to make sure that a is equal to 1, and by a we mean the number in front of x squared. If it's negative, we have to divide both sides by the negative to make everything positive. So there's no way to do this if a is negative. All right, we also want to factor the non-zero side of the equation. That's the side that actually has our function on it, and then we also want to use the zero product property to find our solutions. What's another word for solution? Another word for solution is root. Another word is zero. Okay, so we're looking for where the graph is going to hit the x-axis. That's really what we're looking for here. All right, let's do problem A. Problem A says negative x squared plus x plus 12. Well, the first thing in our first step, it says set y to 0. So I'm going to do that first. It's going to be 0 equals negative x squared plus x plus 12. Okay, and then it says in step 2, make sure a is positive, or a is 1, but it looks like here we have a negative, so we have to multiply both sides by negative 1. Well, if I multiply this side by negative 1, guess what? It's still 0. All right, so if I multiply everything on the right, I have to multiply my 12 by negative 1, my x by negative 1, this whole term by negative 1, and that's going to become positive x squared, negative x, and negative 12. Okay, and now I just have to factor. I have to think about, all right, well, I have to find two numbers that multiply to negative 12, and I have to find two numbers, those same numbers that I find that multiply to negative 12 have to add to negative 1. Remember, there's a 1 in front of that x. Okay, so now, if I think about it carefully, negative 12 could the two numbers that I'm thinking of are going to be negative 4 and positive 3, because if I multiply those numbers, I get negative 12, and if I add those numbers, I get negative 1. All right, so now I have 0 equals these two binomials. All right, and basically what we're going to find is that when we set those two things equal to 0, so I'm running out of space here, I'm going to have to move up here. When I set x plus 3 equal to 0, and I set x minus 4 equal to 0, then I found my two solutions, because my two solutions will be negative 3 and positive 4. Those are going to be my two solutions. That means that that's where the graph is going to hit the x-axis. All right, let's take a look at B. In B, it says negative 12x equals x squared plus 36. Well, everything is not on one side, so I'm going to go ahead and add 12x here and add 12x on the right as well. All right, so that cancels. That basically becomes my 0. And now I have x squared. I'm going to go ahead and put this term where it belongs, right here. And then I'm going to have my plus 36. All right, so I had to manipulate this function in order to get it to a place where I can actually factor it. All right, now I'm going to find two numbers that multiply to 36. All right, I think it's going to be 6 times 6, because 6 times 6 is 36, but when I add them, it becomes 12. All right, so now my two binomials are going to be x plus 6 and x plus 6. And I'm going to take that x plus 6 and set it equal to 0. And if you notice here, there's only one binomial. I mean, there's two binomials, but they each say the same thing. So that means that we've gotten the vertex of the parabola here. So if I subtract 6 from this side and subtract 6 from this side, my one solution for this equation is negative 6. So therefore, the parabola is going to touch the x-axis at negative 6. And so anytime you see the same binomial in your two different brackets there, that means that you found the vertex instead of the two solutions or the two places that the parabola hits the x-axis. All right, we're going to move on to problem C here. And in problem C, it looks like we still have to do a little bit of manipulation of the function. We can't have this negative 36 here, so I'm going to go ahead and add 36 to both sides. And then that's going to make it 0 on the left. And we do have a negative for our x squared term, which we're going to have to do something about. Remember, we can't have a negative there. And so if I multiply the left side by negative 1, that's not going to change anything. That's just going to stay 0. But if I multiply everything on the right by negative 1, that's going to change my sign here to positive. But the sign before the 5x is going to be negative. All right, and then I'm going to have to find a couple of numbers that multiply to negative 36, but end up being negative 5 when I add them together. All right, so my two numbers that I can think of would have to be -9 and +4, because when I multiply them, they come out to -36, but when I add them, they become -5. So I'm going to write my two binomials in, x minus 9 and x plus 4. All right, and I have to set each of those equal to 0, so 0 equals x minus 9, which gives me an answer of 9 for one of my roots, right? 9 minus 9 is 0, so it's going to touch the x-axis at 9. And when I set this one equal to 0, I can see that -4 is another place that my parabola is going to touch the x-axis. So those are my two solutions, or my two zeros, or my two roots. That's what we call them. All right, I would like you to finish this section here, D, E, and F. I'd like you to do and try those problems. But of course, if you have questions, make sure you ask when we get to class. All right, let's go on to example number 2. This is the real-world modeling type situation that we have. Due to the growing popularity of skateboarding, a city is thinking about expanding the size of its skate park. The current park is in the shape of a rectangle, which measures 600 meters by 400 meters. Currently, what is the area of the skate park? Well, area is just length times width, right? So we're going to take the length, multiply it by the width, and we end up with 240,000 meters squared. Okay, so if we take the number of zeros here, that's definitely got to have 4 zeros in it. 1, 2, 3, 4. And the number 6 times the number 4 is our 24. So even if I didn't have a calculator, I can multiply 600 times 400. Now, the city wants to exactly double the size of the current park by adding the same amount of distance x to the length and width. So they're going to add some distance x to each part of the park, meaning to the width as well as to the length. Okay, so if they do that, we need to be able to figure out a quadratic equation for the expansion of the skate park. So we're going to say, well, if we add x to both 600 and 400 and multiply those together, because remember, this is the length, this is the width, and we're just going to multiply them. Well, we know how to FOIL, and that's beneficial to us here because we're going to take our first terms, we're going to take our outside terms, multiply them together, and that's an x there, and then our inside terms and our last terms. We already know that 600 times 400 is 240,000. Okay, so our final equation is going to be x squared plus 1,000x plus 240,000. Okay, and so whatever they get for x, or whatever amount they decide to add on, they could substitute that in to find out their new area of the skate park. Again, if you had any questions throughout this set of notes or throughout this video, please make sure you ask when you get to class.